this is section 5.6, and it's inverse trig derivatives. And like I said, we're nice little baby introduction to this. We're not going to do really hard ones. We're going to do easy ones. So pretty much if you can follow the formula, then you're going to be able to come up with these. So with this just being Calc 1, we're not necessarily going to have to do the really hard ones. All right, I am going to take the time to write them all down. I'm going to put these in terms of u. So again, in these formulas, u is a function of x. Okay, so we just always want to remember when I write our u formulas, they are a function of x. So I'm going to say d dx, all right, of, and your textbook uses inverse sine, or a lot of people will read this as arc sine, all right, but that's the inverse sine of u, okay, where u is a function of x. So it doesn't just have to be an x, it could be an x squared, it could be a 3x plus 1, okay, whatever. All right, formula here is going to be a u prime all over the square root of 1 minus u squared. All right, then we have the d dx of the inverse of tangent of u. All right, and it is a u prime over 1 plus u squared. And then d dx of the inverse of secant. All right, and then u prime all over the absolute value of u, and then square root of u squared minus 1. All right, now I do have these written in the notes this way for a certain reason. I also have a video that shows you how to memorize these. All right, and it memorizes these in this order. So if you need help memorizing, then that might be a good way to do this. But I've got sine, cosine, tangent, cotangent, secant, cosecant, the inverse across from that way. And I wrote it that way a certain way because it helps with the memorizing. All right, so this will be the inverse of cosine of u, excuse me, negative u prime all over the square root of 1 minus u squared. All right, then we'll have the derivative of the inverse of cotangent of u. That's going to be a negative u prime all over a 1 plus u squared. And then the derivative of the inverse of cosecant. And that's a negative u prime all over absolute value of u, square root of u squared minus 1. All right, so hopefully already you've seen a pattern. All right, I wrote these the way I did. I made them in 2 columns because the derivatives match, except for each of these have the negative in front. Okay, so really you're only memorizing 3. All right, you're memorizing sine, the inverse of sine, tangent, and secant, and then the corresponding ones are just negative. Okay, so lots of other ways to remember this, okay? Now, notice I am using arc sine. That's what's in your book, all right? AP test will do arc sine, all right? But what we have been doing, what? An inverse sine function like this. Here, let's just use a u. All right, so it's the same thing. You've got to be prepared, no matter which one of the notations that you see, that you know that they're the exact same thing. All right, so with the little minus 1 right there, or with the arc in front, like arc sine, inverse sine. Okay, all right, so we're all good there. I'm assuming that you were copying down at the same rate I was, so you all ought to be with me. Okay, going once, going twice. Okay, all right, now, like I said, we're going to do straightforward derivatives on this. We're not going to make them hard. Okay, so let's do...
Could you pick that back up real quick?
Yep, sure can. That'll give me a chance to look through the notes and see what exactly we're going to do here. Oh, we may do that. No, you don't know L'Hopital. We don't know L'Hopital's rule yet, correct? Anybody heard me say L'Hopital's rule yet?
I don't think.
Yeah, I don't think so either. Okay, all right. So if you do download the online notes, page 5, I use L'Hopital's rule. We'll learn it later. I think L'Hopital's rule is in chapter 8, so we will get there. It's just I threw that example in, I don't know, a little bit early. Okay, Josiah, you good? Can I move that?
Yeah, you can go ahead.
Okay. All right. So, like I said, we're going to do some straightforward ones. I mean, I am going to expect you to be able to do like product rule or chain rule with these as well. Okay. But let's do an easy start with an easy one here. Let's say I had y equals the inverse of tangent. I'll use the arctan thing there. And then let's say I have a 3x. All right. And again, you know me, I don't usually put the parentheses around it. We can put the parentheses around it. It's not a big deal. All right, and then what? There's my u, right? So my u is the 3x. Okay, now I am going to fold that formula sheet because I don't want to have to keep it.
Do we need to memorize these formulas for the test on Friday?
It says all formulas.
So yes.
Yes. Yeah. Okay, so if you don't have this memorized, then you can't do this derivative. Okay, it's kind of that simple. So here it is. All right, it's a u prime over 1 plus u squared. All right, so u prime, if this is my u, all right, I'm going to do some just real quick here. I'm just going to implement that formula. So u prime, derivative of 3x is 3. All right, and then this formula on the bottom is 1 plus u squared. Well, my u is that 3x, so I'm going to have a 1 plus a 3x, and that whole quantity is going to be squared. All right, I'm showing an extra step here, which I wouldn't really need. All right, 3 over 1 plus 9x squared. Okay, so straightforward. All right, like we will do several that are just plain straightforward. Okay, now if we want to step it up though a little bit, okay, I could throw in e to the whatever. Okay, and it'd still be straightforward because we know e's. I could actually even probably throw in some natural logs somewhere. All right, so let's do another kind of straightforward one here. Let's do like well, and let's not do y equals, since I just done a y equals. I can make them f of x and it doesn't make any difference, right? So let's switch to an f of x. All right, and then let's say it's the inverse of secant. All right, arcsecant e to the 2x. All right, e to the 2x. All right, so again, I don't usually put parentheses around that, but you could, and you may see it in your book. All right, that means this whole thing right here is going to be my u. All right, secant is right here, so we're going to take the derivative in the numerator. We're going to go absolute value of our u, and then square root of a u squared minus 1. Okay, so let's go f prime of x. All right, I need the derivative on top. All right, so derivative e to the u is e to the u prime. All right, so e to the u prime is gonna, I'm gonna show some more steps here. So e to the 2x times the derivative of that 2x, which is just gonna be a 2. All right, so there's my e to the u prime for the derivative on top. Absolute value, all right, absolute value of e to the 2x, absolute value of my u, all right, and then square root of an e to the 2x squared, all right, and then minus 1. Okay, then we just kind of need to clean things up here. All right, now let's stop and think about this. All right, this is an e to the 2x. So if I plug in 0, that'd be e to the 0, which is 1, positive number. If I plug in a 2 for x, that'd be an e to the 4th. So e is a number raised to a positive exponent. It's still going to be a positive number, right? If I plug in a negative 2, that'd give me a negative 4 right there. So it'd be e to the negative 4, which would just be 1 over e to the 4th. So it's going to be 1 divided by some decimal. So still going to be positive. So this value is always going to be positive. Do we all agree? No matter what I plug in for x, this is always going to be positive. So I can drop the absolute value bars since I have just went through positive numbers, negative numbers, and zeros. I know it's always going to be positive. So my numerator can clean up to 2e to the 2x. All right, I can have my e to the 2x here. All right, this would be power raised to a power, so that's going to be a 4x. So I'll have a square root of e to the 4x minus 1. All right, I can clean up a little bit more now because now I can say e to the 2x and e to the 2x crosses out, which then is just going to leave me with the 2 over the square root of an e to the 4x minus 1. All right, nice little cleaned up answer there. So while that is just a straightforward implement the formula, okay, a little bit of thinking here with your absolute value. If you can think that through and you can guarantee it's going to be positive, you may drop the bars. All right, questions on that? Because that was still straightforward.
If we did not drop the absolute value bars and just made it 2 to the EX 2x and had the absolute value in the bottom, would it still be right or would it be wrong?
Technically, it would still be right. Yes, you just wouldn't be simplified into lowest terms. Yeah, but it would be an equivalent answer. Yes, it would be an equivalent answer. If it's something that's obvious, then like the e to the 2x to me is an obvious, yeah, that's always going to be positive. We know e is a constant. But if I just had absolute value of x, then I could not drop the absolute value bars, right? Because x could be -1. So I would need the absolute value bars then. Okay, so I would probably only expect you to do it when I know when it's like a constant, there's a constant involved like that, and it's going to be something you can easily calculate. Okay. All right, I'm going to go to a new piece of paper because I think this next one's going to be a little bit more challenging. We did two pretty straightforward ones there. All right, now let's take a look at one that would involve a product rule, because technically you could do product rule, you could do quotient rule, you can do chain rule, you know, like power rule, which involves a chain. All right, so if I had something like f of x equals, and again, I keep using this notation because that's common on the AP test, but it's also in our textbook. So I think our textbook does do a little bit of switching back and forth, but all right. So two different inverse trig functions being multiplied together, right? Because right there's the multiplication. I've got this one being multiplied by this one. All right, so then I have product rule. Okay, this is an example of how you would implement product rule. All right, and we, if nothing else, just for the algebra of this, we kind of need to have. All right, I'm going to come all the way over here. I think I'm going to need the room. All right, so the derivative. Okay, so I may use ddx notation on this because with it being product rule. Okay, so I do the first function. Okay, so first function times the derivative of the second function plus the second function. Whoa, too many S's and C's and everything else on this. All right, and then times the derivative of the first function. All right, so that's just basic product rule. We know that. We're not going to screw that up. All right, but to make sure that we're not making any silly mistakes here. So I'm going to keep this. So arc secant x, inverse of secant x. All right, now I'm going to pull my derivative sheet up over here. All right, negative u prime all over absolute value of u square root u squared minus 1. All right, so this one is going to be kind of easy in the sense that there's my u, right? So derivative of x is just 1. So my numerator is going to be a -1. All right, over absolute value of my u. So absolute value of an x. And then square root of, plug x in here. So x squared minus 1. Okay, so that derivative is kind of not too bad. All right, now I got to move this piece of paper so we can see. All right, now keep this one. So arc cosecant x. Okay, now derivative of secant. All right, I'm going to pull my formulas back up. Here's my secant, u prime over absolute value of u square root u squared minus 1. Okay, so again, if I do put my little parentheses around that, my u is an x. All right, so this is a relatively nice one here. So derivative of x on my top is just going to be a 1. All right, absolute value of that u, which is the x, and then square root of the x squared minus 1. All right, now what makes this really nice is, can I just multiply that and put that in the top? Multiply this times 1, put it in the top. This one will be negative. All right, so let's do that step. So negative arc secant x all over absolute value of x, square root of x squared minus 1. All right, multiply this times that numerator. So the inverse of cosecant x all over absolute value of x, square root of x squared minus 1. All right, now, did this turn out nice? It did, right? Because I've got two fractions now. I'm adding, and do I already have common denominators? I do, right? That matches this. So it turned out as a really nice derivative. Already got common denominators. Put that numerator together. This is a minus. So I would probably put this term second, put this one first. All right, so arc cosecant x minus the inverse secant x all over one denominator, absolute value of x, square root of the x squared minus 1. All right, and I cannot drop the absolute value bars around the x on this one, because stop and think about it. If I plug a negative in, all right, the absolute value bars it's going to be negative, so the absolute value bars would make it positive. So I need to keep those. Okay, but again, so here's an example of, using them with product rule, with all the other stuff that we have already done. You could do chain, you could do a variety of things. All right, but I am going to keep the functions relatively simple. All right, so my main thing is, if you have the formula memorized, I want the derivative to not be too awful bad. So they're going to be kind of straightforward like this. The key is, if you do this on the test, you have to have that formula memorized, because there's no way you're going to come up with this derivative if you don't know the formula. It's that simple. Okay. All right, now there's a couple more examples, maybe 2 more just straightforward examples in the notes. All right, I think actually about 3 more that I didn't do. Okay, I'm going to move on because I want to take this now that inverse trig derivatives. I should be able to go back and do the types of questions that we have been doing all year long. Write the equation of the tangent line of, and my function could be an inverse trig function, and I could give it to you at some value. So let's walk through that. All right, because especially if I do it at a value of e and I have you plug in e, it can get kind of nasty. So while you know the makeup and the concept of the question, applying it to this new stuff is going to be the task. All right, so let's say it says write the equation of we're going to abbreviate tangent line to y equals the inverse tangent of, and I am going to put parentheses around this, natural log of x. All right, and then at x equals e. All right, so we know natural log of x. We can take derivative there. Okay, so it'll make it a little bit more challenging there, but those are our 2 things. So we're doing an inverse trig function, and I threw in the natural log, and we're going to evaluate this d. So we got a lot of things going on, right? So first of all, I need to, if we're doing equation of the tangent line, I got to find the slope. I got to find the derivative to be able to find the slope at e, right? So my first step, actually, let's go ahead and go to a different color. So let's find that derivative. Okay, and again, see, you would be stuck if you don't have the derivatives memorized. Where the heck did my derivatives go? All right, I want to look at them. Okay, so tangent is u prime 1 plus u squared. U prime over 1 plus u squared. Okay, so u prime. All right, so here's my u, right? Natural log of x. What's the derivative of natural log of x? Gotta wake up this morning. Somebody tell me.
1 over x.
Thank you very much. So 1 over x is going to be in that numerator. All right, that's okay. It's going to be yucky, but that's okay. And then we're going to have a 1 plus a u squared. All right, well, our u is natural log of x. So natural log of x squared. All right, so that's my derivative. Now, technically, I mean, we're going to plug in e, right? But we could simplify it. Might make it a little bit easier if we simplify it first. I mean, I don't know. It's a choice, all right? But that clearly is the derivative. But it's a complex fraction, right? And you know that I like you to simplify those. So multiply through by x, multiply through by that least common denominator, all right? And multiply this times x. Okay, so the x's are going to cross out there, right? So that's going to get down to just a 1 in the top. All right, now, do I want to? We would not necessarily have to distribute that. Let's just go ahead and leave it as x times a 1 plus natural log of x squared. And then, let's put that over there, and let's put that 1 in the center because that looks really tacky now the way I wrote that. Okay. All right, I think for evaluating, I think that's going to be easier now. Okay, so there's my derivative, okay? All right, and normally I have you box that in because if I'm doing this on a test, I'm going to grade that to make sure you have that part right? Now we need to plug in e, so y prime of e. All right, I'm going to have a 1 over, then I'll have an e, 1 plus natural log of e squared. All right, now, do we know the natural log of e? What's natural log of e? Someone's got to give it to me. I'll wait patiently. Do we have that memorized?
1.
Thank you. All right, so it's 1. You got to have that memorized. If I know this is 1, 1 squared is 1, 1 plus 1 is 2. So that makes my slope 1 over a 2e. Okay, so there's my slope. All right, so again, you got to have that natural log of e memorized, not screwing up there. Okay, now I need a point, right? And they didn't give me the full point. They only gave me the x value. So I got to come up with my point. All right, now my point is going to be on that original curve, and I know x is e. So I'm going to start out with y equals arc tangent of natural log, all right, of x. I'm just writing the function down right there. All right, now let's plug in an e. So if I'm evaluating this, plugging in an e, so arc tangent of natural log of e. All right, well, we've already done natural log of e. We did it down here. It's 1. So now arc tangent of 1. Okay, let's put y equals in front. Okay, now this is from yesterday's lesson. All right, I'm trying to find the inverse. All right. So actually this I could write as y equals tangent inverse of 1, right? I could do it like that, which means what? I'm trying to find the angle where tangent equals 1. So from yesterday's notes, I don't need a y equals. I'm trying to find a theta such that the tangent of theta equals 1. That's what the inverse function is. I'm trying to go backwards. I have the answer, which is 1. I'm trying to find the angle. All right, this is where you're going to use your unit circle. Think unit circle, get it out, look at it. I'm going to be patiently waiting here. Okay, where is tangent 1?
Pi over 4.
Pi over 4. Okay, because on the 45-degree angle or pi over 4, that's always where, excuse me, sine and cosine match. Anything over itself is always 1. So our theta is pi over 4. Okay, which means then my point, I'm going to run out of room because I've wrote too big here, is e pi over 4. So I had to go to actually a lot of work and use yesterday's lesson to actually come up with that point, then to be able to write the equation of the tangent line. So then now I've got a point, I've got my slope. So my tangent line is going to be y minus pi over 4, put in the slope, 1 over 2e, x minus e. All right, and then I would not do anything to that. I would leave it in that point slope form and call it quits then. Okay, so applying that to stuff that we've already done. All right, so a little bit of yesterday's along with the new inverse trig derivatives. Okay, can I stop sharing? Are we all good?